Hey everyone, welcome. So this is going to be the final lecture and bit of material that you're going to have to know for the course and for the entire year. I won't be posting anything else this week except the unit test, which I'll give you ahead of time on Friday. So you'll have some time to work on that. And that'll be due by next Friday, which is the last day of classes. So we're in the home stretch here, and I was debating on whether or not to cover this specific method of solving linear systems, but I think it is really helpful, especially just in the general sense of if you choose to go on and further in math, for the very small percentage of you that will, this is for sure a strategy that helps make you overall better problem solvers. And we're just dipping our toes in this. It's not anything all at once here. It's very manageable. So we're solving by substitution, and substitution we've used before. Right? When we've had something that's when we've had let's make this a little bit less thick. When I've given you like an equation 4x minus 7y equals 21, and check if 3, 2 is on the line. I've given you something like this, and you've used substitution before. Is on the line, and what you did, we said that this was our x coordinate, this was our y coordinate, and we're going to plug those into our equation. So we got 4 times 3 minus 7 times 2 equals 21, right? And what does this become? Well, it becomes 12 minus 14 equals 21. This is negative 2 does not equal 21, therefore not on the line. Great. And this was kind of a clunkier method for solving linear systems, right? Because it was basically a guess and check. There was no way for us to know whether or not what the actual point was going to be. This was just saying, hey, let's choose a point and let's see if we can plug it in, right? So it's kind of clunky. But with the substitution method, we're going to be using the same thing, but we're going to get an exact answer for solving a system of equations like this. And the way that we're going to do it is we're just substituting in bigger chunks. So I can give you an example of this. So example, write the new equation. Write the new equation of 4x minus 6y equals 2 if x equals let's say x equals well, it doesn't really matter, y plus 2, and y, we'll make it a little bit bigger, y equals I'm going to put these in brackets to show there, x plus 2x squared. Okay. So we have similar things here. We have a value that y equals over here. We have a value that x equals over here, and we know what those equal. It equals these big things right here. So what we can do, we can plug those into our equation, just as we've done up here before, except it's just going to be a bigger thing that we're plugging in. So we have, let's start with our beginning of the equation. So we got 4 times, and what did we say x was? Well, we said that x was y plus 2. So I'm going to plug that in here. Y plus 2. We'll seal off the brackets. Minus 6 times x plus 2x squared. 6 times x plus 2x squared equals 2. And we can redistribute all of this, right? Because we know how to do this from factoring. We're just going to take the negative 6 over in the x plus 2x squared and distribute that, multiplying it, and then this 4 will multiply it into here. So we get 4y plus 8 minus 6x minus 12x squared, right, equals 2. And we're basically at the new equation right now, right? So we could move that 8 to the other side, where we would get, instead we would have this equation here, 4y minus 6x minus 12x squared. Usually you write this in the reverse order. You put the x squared first, but it doesn't really matter for this case. And minus 6. So that's just an example of how we're substituting in these bigger chunks that we're substituting in. So bigger chunks. Right? Bigger. Actually, we'll do this. Bigger chunks, right? So that's good. Great. So what do we do? How do we move on from this? Well, we just have 3 examples I'm going to walk you through just to show you different ways we can go about solving this. So the goal is we need to solve a system by substitution, but the only way that this one is different than this example one is different than the one up here is that up here I gave you what x was to plug in. I gave you what y was to plug in up here. When we're given something like this down here, we don't have those specific values, so we need to rearrange we need to rearrange the equations to help solve. And the way I would do this is I wouldn't just choose one equation to rearrange. Let's rearrange both, and we're going to put them in. Well, actually, it doesn't really matter. So you can either choose to isolate y in one equation, or choose to isolate x. And it doesn't matter which one you do. So I'm going to show you two different ways that we can do this. So and you're going to look at this in a very strategical manner. Like if in this case, so we're looking at x plus 2y equals 3 and 2x minus 4y equals 22. Which one of these two equations do you think is easier to simplify x and y? Well, I would argue that equation 1 is easier, right? Equation 1 is easier because x is already on its own. So we know that we're not going to have to divide by anything. And all we have to really do is just move this 2y over here, right? We just have to move that 2y over there. So let's do that. I'm going to isolate x in equation 1. So isolate x in equation 1, okay? So to do that, it's just going to become x plus 2y equals 3, and then x equals, I'm going to subtract 2y, 3 minus 2y. Well, hey, now that we have this, what if we plug this into our second equation? Because we can do that. And let's see what happens. Let's plug in x over here to our second equation, and you'll see what kind of falls out of this. So let's write this down here. Let's plug in. And you can't plug this in to the same equation because you won't get anything out of it. Like nothing special will happen with it. You have to plug it into a different equation, that one that you haven't rearranged yet. So let's do that over here. And if we do that, we get 2x minus, oops, sorry, I'm already breaking my rules here. What did we say that x was? We said that x was 3 minus 2y, right? So we're doing that. Minus 4y equals 22. And we can solve this. So let's distribute this 2. So we get 6 minus 4y equals 22. And minus 4y, so we're at 6 minus 8y equals 22. And what can we do? We can move that 6 to the other side by subtracting it. So we get negative 8y equals 16. We divide by negative 8, and we're left with y equals negative 2. So just like that, we've been able to solve this without even doing our subtraction or addition method, and we've got what the y coordinate is for the system of equations. So now you know what to do from this point out. You know exactly what to do, and we just need to plug into another equation. So plug into the equation, and this one you can do 1 or 2. 1 or 2. And I'm going to do equation 1 because equation 1 is simpler. So I'll bring this up over here, and let's see what we get. So we get x plus 2 times negative 2 equals 3. X minus 4 equals 3. X equals negative 4. Add that to the other side, and we get 7. So therefore, solution occurs at point 7, negative 2. Great. So there's one way of doing it, and then this one I isolated for x, right? You could do y, So let's try one where it's y. And again, we're going to look at this strategically. Which one of these two equations here is going to be easier to isolate for? And again, it's going to be equation 1 in this case because y is already on its own. So let's just get y. Or there's no coefficient in front of y. So let's just get y on its own. So we do that. And what do we get? Well, we get negative y equals 3 minus 4x. Okay. And what I'm going to do, since I don't want a negative y there, I want a positive y. I'm just going to divide everything by negative 1. And what's going to happen is it's going to flip the sign on everything. So we're going to actually have 4x minus 3. Okay. And you can, again, these are completely rearrangeable. You don't have to put them in the order that I'm putting them in. I prefer putting them in this order, though, where my highest degree variable is coming first, followed by everything else, right? Okay. So we know what y equals. Let's plug this into, let's plug into, and it has to always be the other equation when you're doing this. When you're plugging it in, plug into equation 2. Okay, so we have 6x. So let's call this step 1. This is step 2. Equation 2 is 6x minus 2 times, what was it, 4x minus 3, all right? Because I'm plugging a y here instead of just regular y, equals 5. Let's distribute this, 6x minus oops, that would be 8x plus 6, right? We have to be careful with this negative and the negative here when we're multiplying, equals 5. 6x minus 8x, well, that's just negative 2x. And I'm going to move that 6 to the other side. So that would be minus 6. And minus 6 is, or 5 minus 6, well, it's just negative 1. Divided by negative 2 on both sides to get rid of that 2. And we get x is equal to 1/2. Great. So there's our first x coordinate. There's our first x coordinate. And let's call this step 3. Plug into 1 or 2, right? Plug into 1 or 2. I'm going to choose the easier one because I like easier. So we got 4 times 1/2 minus y equals 3. Okay, 4 times 1/2, well, it's half of 4, that's just 2, minus y equals 3. Negative y equals, I'm going to move that to the other side, so I'm going to subtract it, 1. Divide by negative 1 on both sides, and we get y equals negative 1. And so therefore, the solution occurs at point 1/2, negative 1. And with that fraction, you could write it as a decimal for sure, 0.5. Preferably, I would just leave them as improper fractions. So I've seen a couple folks convert it to a proper fraction. That used to be the case when you were back in public school, but it's really never used past public school. So you don't have to worry about ever doing it in improper fractions. So there we go. The solution occurs at 1/2, negative 1. And we'll do one more just to mix things up here. And again, we can use some kind of nice strategies in this one, right? We can use some nice strategies. So which one? Take a minute, pause the video, and ask yourself which one of these would be easier to isolate a variable for. And some of you might be like, well, none of them are really nice, right? Because they all have a coefficient in front of their variable. Well, what about this one though? What can we do with this one? Notice what each coefficient is. We have a 2, we have a negative 6, and we have a positive 12. What do 2, negative 6, and positive 12 all have in common? Well, they're all divisible by 2. So we can divide by 2 just to simplify it. Nothing will change about the equation because nothing changes as long as we do the same thing to every single term. So we get x minus 3y equals 6. Okay, nothing changes about this. Now we can let's solve for x, right? Because x is already on its own. It has a coefficient of 1. So we get x equals 6 plus 3y. Look how easy that was. That was even in less steps than what we did before. X plus 3y. So now we're going to plug into, we can't do it in equation 2 because that's the one that we just isolated for. We have to do it in equation 1, okay? So we have 10 times, what did we say x was? We said x was 6 plus 3y minus 5y equals 14. Beautiful. Let's distribute that 10. So we get 60 plus 30y minus 5y equals 14. So we're going to do 14 minus 60. 14 minus 60, which is, what is that? Negative 46, right? And then we have 30y minus 5y. What's 30 minus 5? That's just 25. That's just 5. So I want to make sure that I am keeping up here. Yeah, okay, we're good. And with this, we're just going to divide through. So we get 25. And we get y equals negative 46 over 25. And I do not think that is reducible by anything. So sometimes you'll get a not nice number like this, and we can just leave this as is just for the sake of it. So negative 46 over 25. So now we got to plug this into, I'm going to plug it into equation 2. Oops, it's on 0. Because equation 2 is dealing with just smaller numbers. And again, we can use this. We can use this over here, right? We can use this, no problem. Let's use the simplified version. So we said that x minus 3 times negative 46 over 25 equals 6. And this one's kind of ugly, so let's just deal with this as is. So we're going to take this, pretend this is a 3 over 1, right? Because we can write out a fraction like that. Let's do 3 times 46 and see what we get. 3 times 46. 3 times 40 is 120 plus 3 times 6, which is 12. It should be 132 if I did that right. Negative 132. Let's just double check though. 3 times, oh, actually it'll be positive because we have a 138, sorry. Oh, 3 times 6 is 18, that's right. 138. So it'll be plus, right, because we have 2 negatives multiplying, 138 over 25 equals 6. X equals 6 minus 138 over 25. And this I would just do this on the calculator. 6 minus 138, 6 minus 138 divided by 25. It's about 0.48. Or I'm just going to simplify that to, we'll just go 0.48. Okay, so therefore, solution occurs at, actually, you know what? See if I have my calculator on me. No, I don't. Well, let's see if, whatever. Negative 46 over 25, comma, 0.48. Just do something like that. So that's a bit of a weird one, but sometimes you'll get that, and don't be freaked out if it's a weird number. So I might have also, I don't think I messed that up, but there's a small possibility that I might have. So that's it, folks. You made it. So thank you for tuning in. Unfortunately, I won't be able to send you off with any personal goodbye because it's school's next for the end of the year, but that's it. So well done, everyone. This should give you a pretty good foundation for what you're going to get next year. We didn't get into trigonometry. We didn't get into finance. I wish we got into finance because that would have been way more useful than trigonometry, in my opinion. But this is where we're at. We've made good progress, and it's been a pleasure teaching you folks. So if you have any questions, please let me know. And other than that, yeah, this is going to be the last official time that you hear from me. So take care, everyone. It's been a pleasure. All right. Have a good one. Have a wonderful summer.